building, they understand defects in building construction, and they understand where water intrusion is likely to occur. And you know, the rule is wherever there's water intrusion that's left alone for a while, the chances are that mold will follow. And so these people were very good, in fact, at finding mold without using any sort of specialized equipment at all. They had a very good intuitive feel for where this was going to show up. If you're in situations where you think you have mold, but you can't find it, and the building inspector can't find it, or if you're in situations where you want building declared absolutely clean, you can do no better than to find somebody who has a mold dog. That's an animal that's specially trained to detect mold. We used to make, still do, in fact, not my company anymore, but the successor business, in fact, makes training kits for mold dogs. These are pieces of substrate which are infected with various species of mold that are common in houses, and the animals are trained on. And they're very good. They can detect mold behind walls almost unfailingly. And I know I was involved with inspection with one building here in Eugene where, you know, I in fact had been in the building and looked around and said, yeah, it smells kind of funny, but I don't see anything. And in fact, a mold dog was brought in, you know, within 15 minutes. It detected where the mold was. So there aren't many of those around, but if you're really seriously concerned about it, that's about the best you can do. Well, let me say something about air sampling. Now we move into the realm which is perhaps more of interest to the building inspectors, but the issue is, so you're pretty certain you have mold. Who do you hire? What do you do? What kind of information will you get? And what sense can you make of it? Well, let's talk first about air sampling. Air sampling is the most common form of sampling that is done in the mold industry. Real estate people just love them. They love them because what they really want the lab to tell them is that there's no problem and the house sale can go forward. They can send in a sample, somebody will count the thing and send the information back to them in a matter of a couple of days. It was never clear to me why this couldn't have been done, say, a month in advance, why it was always a rush sort of thing. Having said that, I need to tell you that there are dire problems with air sampling as it's normally done. So what's done is you have a pump which pumps in a known volume of air through a filter. It's not a filter, actually. It's a kind of a sticky surface on which spores in the air are allegedly impacted. And then you send them to a lab, and somebody who's paid to sit down and do the soul-destroying task of counting the spores under a microscope will send back a report. As I've worked with this, I became more and more convinced that, in fact, most of that information was totally worthless. Why was it worthless? The devices which impact the spores are inefficient. So many spores, which in fact are in the air, don't stick to the filter. The samples are not replicated, which means that, in fact, unless there are absolutely huge differences, it really is impossible to say statistically whether there's any difference between the outside air and the air inside the house. They're not replicated because it's expensive to replicate samples. But, you know, there was always that very basic scientific consideration. The data is essentially worthless because there's no replication. Then, I'll tell you, about 18 months ago or so, somebody in the Midwest who's an academic but who works on air sampling technologies came out with a study which should have been highly disquieting to anybody who does this. So this person worked in an area where the spore concentration of the air was relatively constant. And he made a number of replicate samples and sent them out to different laboratories to see what the results might be. And then, when the results came back, he did a regression against various variables which might have made a difference in the numbers that were reported. Well, what do you think the most important variable was? how much did it cost to analyze the sample? That was the most important variable. And the people who were charged $65 a sample always found 2 to 3 times more spores than the people who charged only $25 a sample. That's because it takes more time. They counted more of the filter, and they were more careful about looking for spores in various places. Well, that ought to be highly disquieting, but wait, it gets worse. So the person who was doing this study, who was very adept at counting spores and filters, said, well, I think I could probably do better than any of the labs out there. And so, in fact, he counted them himself. He corrected for various things like spores that were in and out of the plane of focus under the microscope, spores which had bounced away from the trace where the impaction took place. And he found 2 to 3 times more spores than the very best laboratories that were out there. So the suggestion is that, if you send it to just any old lab, the number you get back could be anywhere from 2 to 10. The real number could be anywhere from 2 to 10 times larger than the number reported on the sample. And, you can always say, well, don't blame the messenger, but I mean, those are the facts, folks. And so there are other problems. There's huge variability too. Recently, people have come out with sort of automated spore samplers where you can sample for 24 hours and then sort of integrate over the time period. You really need to do that because in houses, when the furnace comes on, there's a draft coming through the air, then all sorts of spores are blown up in the air. The counts go way up. People move around in the house, the counts go up. What number are you using? I've never been a fan of just plain air sampling for that reason. Unless you have huge differences. I mean, differences. There are 100 times more spores inside the house than outside the house. Then you might want to think about taking some sort of action, getting, other things. Now let me show you some pictures here, and maybe you get an idea. Now, this is a sample from the tape lift. In fact, it's a beautiful species of penicillium, and you can see the little round rough spores scattered all over the place. These are the spores that largely we're talking about. And here's a species of Aspergillus related to penicillium, also making little round spores. And here's what you might see on an air filter taken from a very bad situation. Okay, a bunch of little round things. So the problem is, as I said, difficulties in counting, and there are additional problems. And let's go on to talk about other kinds of air sampling. The air sampling that we found most useful as we got more experienced in this was called viable spore sampling. And when you do viable spore samples, what you do are impact the spores on a plate of medium which has goodies in it, in which the fungi will grow. And what this means is that the lab was looking at these things. Well, they can count the colonies easily. But more important, they can identify the fungi which happen to grow up. So then you're going to know, well, have I got Aspergillus parasiticus, which is one of the most potent mycotoxin producers known. We got samples from a place where Haitian refugees were being housed in southern Florida after one of the hurricanes. The walls were absolutely impregnated with Aspergillus parasiticus. It cannot have been a good place for those people to be. On the other hand, if you've got cladosporium with many fungi which don't make mycotoxins, there really is no particular concern at low levels. So being able to identify things is really very important. I'll tell you one more story. Got samples from a trailer house in California somewhere. And there were various kinds of samples. It was a good mold inspector. But in the air samples, there were 60,000 spores per cubic meter of little round black spores. And, little round black spores can be quite a number of different things.